Unit 5, Writing Classes. Topic 5.1, The Anatomy of a Class. As programmers, we store data to access, manipulate, and share in creative ways. We have learned how to store individual primitive types and string reference types using variables. In this unit, we will explore how to store multiple variables and methods using a class. A class is a formal implementation or blueprint of the attributes and behaviors of an object. In Unit 2, we learned that a class is often called a blueprint because you can construct multiple objects from it. We use the example of 3D models like this one that can be used to create multiple 3D printed objects. They all share similar attributes and behaviors but are unique in their own ways. UML diagrams can be used to visually represent programs. This is a basic UML diagram of a class. You should be comfortable drawing these to help you construct code for FRQ question Style 2. Look at these highlighted terms, public and private. The keywords public and private give programmers the opportunity to provide access or not to certain components in their code. The keywords public and private affect the access of classes, data, constructors, and methods. The keyword private restricts access to the declaring class, while the keyword public allows access from classes outside the declaring class. Let's look at how to construct the anatomy of a class using the UML diagram. Classes are designated public. The class header consists of the keyword public, followed by class, and then the name of the class, which is capitalized. Access to attributes should be kept internal to the class. Therefore, instance variables are designated as private. Following the class header, you will then declare the private instance variables. Notice that these are not initialized or assigned a value at this time. Constructors are designated public. After the declared instance variables, you should then write constructor methods that will be used to construct objects of the class and initialize the instance variables. Notice that these are public in order to be accessed when instantiating objects outside this class. Here we have a default constructor with no parameters and an overloaded constructor with parameters. The keyword this is used to differentiate between the instance variables and the corresponding parameter variables when they are given the same names. The keyword this refers to the instance variables. Access to behaviors can be internal or external to the class. Therefore, methods can be designated as either public or private. The provided accessor and mutator methods in a class allow client code to use and modify data. It is common to create accessor and mutator methods, or getter and setter methods. Accessor methods gives access to the values stored in the private instance variables. Mutator methods allow you to modify or change values stored in the private instance variables. In Java IDEs, it is common once instance variables are declared to generate getter and setter methods for each instance variable. Data encapsulation is a technique in which the implementation details of a class are kept hidden from the user. Instance variables are encapsulated by using the private access modifier.
Encapsulation in programming is really important to understand because it's going to make your code much safer to execute. Now let's say you have some kind of variable. You have a bunch of code wrapped up in a function. Now you can imagine if these were available to all of the software running in your program, all of the various functions and loops and things. And then imagine you came along and you forgot that your variable was called I, and you used I in here. Well, these two things would start to interfere and you'd get all kinds of weird, almost untraceable bugs. So this is where encapsulation stops this kind of behavior. And how it does that is primarily by wrapping these things up inside classes, which you should be familiar with by now. So in our class, we have a bunch of variables and we have a bunch of functions or methods. And all of these items we can make private. And what does private mean? Well, private means that some other class, function, variable, doesn't matter what, cannot access these directly unless I make some of these public or I allow the functions to change the variables themselves inside of that class or the instance of that class. So that means in practice, when you have I in a class, some other class can use I, and never shall the two be confused. They are completely different. And encapsulation also actually happens inside of classes themselves. So if I had a function like this, and I used I inside of it, and then I had another function, which I'll call j, and I used I equal to naught in there, these two would have no idea that the other one existed. And this is called scoping, in a way. It means that this I is only available to this function, and likewise with this I. And of course, there are ways to override this, but in general, you don't really want to override that behavior, because encapsulation allows you to encapsulate things that shouldn't be modified by other parts of your code.
When designing a class, programmers make decisions about what data to make accessible and modifiable from an external class. Data can be either accessible or modifiable, or it can be both or neither. Let's practice. Here's a class called Snack that has private instance variables, a default constructor, an overloaded constructor, followed by methods that are either public or private. Which of the following lines will cause an error, if any? Line F is trying to access the private instance variable calories. This line will cause an error. Line G is trying to call the private method canEat. This line will also cause an error.